Hi, my name is Fatima, and this is your Belmont Math Science Center tutor tip. Sometimes students have trouble with periodic table trends, so I'm just going to be talking about the general ones today. So to start, we'll be discussing atomic radius, which is 1/2 the distance between the centers of two atoms of an element that are briefly in contact with each other. Atomic radius increases from right to left and decreases from bottom to top. This is usually because as protons and electrons are being added to an element, which this happens from left to right, they are being held closer together to the nucleus, which tends to decrease atomic radius. We see this in the other trends that we will be discussing. Now we will be discussing ionization energy, which is the energy required to remove an electron from gaseous species. Ionization energy increases from left to right and decreases from top to bottom. This is because as you go from left to right, the electrons are held together, so it's harder to remove an electron. This is also seen in electron affinity, which is the energy emitted by a gaseous species when it gains an electron. So in the trend of electron affinity, we see that it increases from left to right and decreases from top to bottom of a column. The last periodic trend which we will be talking about today is electronegativity. So electronegativity is a measure of the attractive force that an atom will exert on an electron in a chemical bond. This also increases from left to right and decreases from top to bottom, similar to the two trends discussed previously. So now we're going to do some sample problems. So first we are going to look at the increasing electron affinity of barium, copper, sulfur, and yttrium. So just pause and take a moment to determine it. Then when you're ready, we can start. So I've gone through and highlighted the elements we're looking at. So based on our electron affinity trends, it increases from left to right and from bottom to top. So barium would have the least electron affinity, with sulfur having the most because it's farthest to the right and near the top too as well, showing that it's going to have a higher affinity to gain an electron versus barium. So now in our next problem, we're going to rank the following elements by decreasing electronegativity. So I'll give you a chance to work on this by yourself, and then we can work on it together. So we know that electronegativity increases from left to right and from bottom to top, because the further right we go, the more the atom wants to keep its electron. We also do have an exception to electronegativity, which you're going to see in this problem, is that the noble gases tend to not have an electronegativity because it doesn't want to form its bonds. So I'm just highlighting the atoms we are looking at, and we see that oxygen is the most electronegative, with neon being the least electronegativity because it does not form bonds. So in our last problem, we're going to rank by increasing atomic radius. So we know that atomic radius increases from right to left and decreases from bottom to top. This aligns with our other periodic table trends of electronegativity, electron affinity, and ionization energy. So first we're going to mark the elements that we are looking for on the periodic table, and then we will rank them. So we see that since bromine is furthest to the right, it will have the smallest atomic radius in comparison to cesium, which is furthest to the left and near the bottom too as well. This also aligns with our trend of electron affinity, electronegativity, and ionization energy. And here's just a general overview of all the periodic table trends on one periodic table.